Remember, we'll have a test review on Chapter 2 next class, and your test will be the following class. So for you, for B Day, it will end up being Wednesday. For A Day, it will be Tuesday. Quadratic graphs and their properties. Essential question. What is the parent function of a quadratic, and how does the equation change when the graph is shifted? This is huge. For the rest of your math career, you're going to be given functions. If you know what's called the parent function, which today you're experiencing your first parent function, you know the parent function, you should be able to look at the equation and all the numbers around that parent function. You should know without graphing it what happens to the graph. Secondary 2, secondary 3, you take 1050, 1060, calculus. You have to know your equations. And you should be able to look at the equation just by looking at it. Tell me exactly what's going to happen to the graph. Okay, so a quadratic. Who's heard the word quadratic? Oh, a few of us. That's good. So the standard form for a quadratic is y equals ax squared plus bx plus c. Where a, b, and c are just numbers. There's an x squared. Quadratic has the highest exponent of 2. X squared means it's a quadratic. So, this would be a quadratic. Y equals 3x squared, because it has the x squared, and that's the highest power. Another one would be x squared plus 9. Y equals x squared plus 9. That's still a quadratic. Because the highest exponent is 2. That's x squared. Another one, we could even have a trinomial. As long as that highest power is squared, the degree of the trinomial is squared, then it's a quadratic. The parent function is what we call the basic, most simplest form of that. The most simplest form for the parent function would be y equals x squared. Because all of those have y equals x squared in it, right? All those in green have y equals x squared. So that's the simplest form. Then we just added numbers. We've added a multiplier of 3. We've added plus 9. We have some other stuff here. But the most basic form of it is y equals x squared. And from there, if we add numbers, stuff happens to the graph. So, let's figure out what the graph looks like. Oh, that's the next one. What does the graph look like for y equals x squared? And we can do that by getting a table of values. Okay, when we are looking for color I want. Okay, when we're looking for a graph, you need to plot points, and I would not graph any less than 5 points. So always at least do 5. You can do a vertical x, y table to get points like that. You can also do it horizontally, based off how much room you have on your paper. Okay, I'm going to go from -3 to +3 and collect points. What this means is I take this x value, I plug it into my equation, and get the y value. The input will pop out an output. So if I did a little bit of work, y equals -3 in parentheses squared. Because it was x squared, so that x, I put a -3. What do we get when we square that? +9. I go to my next x value. Y equals -2 in parentheses squared. What would my output be? 4. Y equals 4. So in the y column we put 4. Okay, I don't think I have to write the work on this because I think you guys know what's going on. -1 squared for the next one. +1. 0 squared. 1 squared. Oh, interesting. 2 squared. Oh, interesting. 3 squared? Oh, interesting. What has happened?
One side is negative. Like
On
0.
one side is the same.
Ah, the same numbers start popping out. We have a turnaround point right here at 0, 0, which we'll talk about what that is a little further on. But you can see the y value is 9410, then it repeats and starts going back up, 149. So let's draw a graph to see what it looks like. Don't make your graph itty-bitty, large enough that you can actually see what's going on. We have an x-axis, and actually, look at my y values. Are any of those negative?
No.
No, so I'm going to put my x-axis lower and do an upside-down T. No, that is not a line. Because none of my y values are negative, so you can do all 4 quadrants if you want. But always make sure you have arrows in, because it is a line. A line goes on forever in both directions. Make sure you label x. Make sure you label y. Have to be in the habit of labeling. Okay, we're just going to go through and plot those points. So, here's some errors I see people doing. On the x's, I go from -3 to +3. So some people start over here on the left and go -3, -2, 1, and then there's this huge gap. They need to be evenly spaced. What's a better way to mark your tick marks so that they're evenly spaced? Yeah, start where? Start at 0, meaning the origin. Start at the origin and work your way out. -1, -2, -3. Make sure you label. Again, start at the origin, +1, +2, +3, and label. That way, they're evenly spaced out from the origin. Same with the y. Start at the origin. How high do I need to go on the y? 9. 1, 2, 3, 4. I like to make my 5s a little longer. 6, 7, 8, 9. And I label at least a 5. Label one of them so I know what I'm counting by. And so Ms. Gray knows when she grades the test what you're counting by. Now we can plot the points. So let's make these points large enough so when we draw through them, we can still see the points. If I start here at 0, 0, tell me how to get to the point -3, 9. Let's have Gabe. If I start at the origin, how do I move to get to -3, 9?
Go left 3.
Right, left 3, up 9. A nice thick point. Okay, Cindy, what about -2, 4 from the origin? How would I move? So left 2 and then up 4. Good. And you guys can probably do the rest. -1, 1, 0, 0. And then you see repeats. Repeats in heights. It kind of looks like a V. What else could it look like? A U. This is actually a U. A V will be a different function we are doing later on in the year. So when you connect these, make sure that at the very bottom here, you curve it. Make sure it's not at a point. Make sure you curve it so it's actually a U. So what shape does this quadratic look like? It looks like a U. Do we have a name for this U? Some of you have already heard the word quadratic, so does anyone know what we call this U? Starts with a P. You know what?
I don't know like that. I remember like
Okay, it's called a parabola.
yeah.
Good, okay, sparking some memories here. We call this a parabola. And as you guys have already noticed, repeat in the heights of those points, you can fold a parabola. You can fold a parabola so that two sides match up exactly. What happens when we can pull something in half and it matches itself? What do we have? We have symmetry. Good. And this is called symmetry. You can fold a parabola so that the two sides match exactly. And this is called symmetry. And that fold line has a name. Right, where we can, that vertical fold line, oh, I'll have more there, has a name. If I took my highlighter right here, this would be the fold line, correct? The y-axis, which has a name. No, and she actually said the word axis. It's not always on the y-axis, but it is another axis. We have the x-axis, we have the y-axis, and this fold line is called the axis of, what was that word you just told me? The axis of symmetry. Because where this orange dotted line is, so you can fold it right there, and it's symmetric. So that fold line, the fold line that divides the parabola into two matching halves, is called the axis of symmetry. And oftentimes we abbreviate that AOS, capital A, lowercase o, capital S, because the word of isn't very important, so it's lowercase. AOS, axis of symmetry. Fold line that divides the parabola into two matching halves is called the axis of symmetry. The highest or lowest point of the parabola, because sometimes our U opens up, that's called concave up, it would have a minimum point. But sometimes the parabola opens down, that's called concave down, so it would have a maximum point. The minimum point, if it's opening up, or the maximum point if it's opening down, that's a vocabulary word. Do you know that one? Close. But sometimes it's max, sometimes it's min. So depending which way it goes, we have one word for it, vertex. And that's the transition point from changing from increasing to decreasing, or from decreasing to increasing. And we secretly already found the vertex on our table up above. So on the graph we did up above, I can scroll to it in a minute after you guys are done writing. The graph we did up above, look at our table, our XY table. Can you locate the vertex? And it's a point, it has two coordinates, though. So I'm talking about this guy right here. And I already boxed it. What's the vertex? 0, 0, because that's the transition point when it starts repeating itself. It grows back out. That is the vertex. So on your homework, I want you to identify the vertex from a table. That's how you do it. And from a graph. So if it was the graph, you would just look at it and see that minimum point, or sometimes the maximum point. And that vertex would be 0, 0. The vertex. 0, 0. So make sure you write the vertex as a point, the next coordinate, and a y coordinate.
Is it always like in the y-axis?
No, sometimes it'll still be shifted around. Okay, first example. What are the coordinates of the vertex? Is it a maximum or a minimum? Now you know what a vertex is. I think you can find it. Yeah? Scroll it up.
Thank you.
Is that good enough? Okay. When you're ready, find the coordinates of the vertex and decide if it's a maximum or a minimum. Coordinates are those in parentheses. We have an x coordinate, comma, y coordinate. So you should have two numbers. X, comma, y. Give yourself a note at least of what you're answering. So many great looking notes are highlighted. They're awesome. Find it? Okay, so sketch the graph so you have it in your notes so you know what that means. maximum or minimum? That's part of the answer. So make sure you fully read the directions. Good. Actually, I don't think that's the correct coordinates. Yeah. Okay. Fatima, what did you get for the vertex? What are the coordinates? So 2, 2 is right 2, up 2, right there. Is that the vertex? It has to be the highest point or the lowest point, depending if it's concave up or concave down. What?
0,
0, 3, okay, that means stay at the origin, go up 3. Is that the vertex? Yes. Is that point a maximum or a minimum? Because a maximum means highest point.
How do we know if it's a maximum?
Okay, so a maximum hits a max. Max means highest, like that.
Oh.
Minimum means it hits a low point, like that.
Oh,
Min, this is max. Okay, so on your homework you have to identify the table where you look at those y values and find that turnaround point, and from a graph. You think you can do that?
Yeah.
Okay. And we're moving on to example 2. Now we're going to start identifying, just by looking at the equation, some shifting that's going on. Okay? Would you write this on the top of your paper? Because we're going to be using this all year. No, it can be just on example 2. Y equals A times the quantity x minus h squared plus k. Y and x are the only variables that will end up in the equation. AH's and k's are numbers. So in example 2, it says graph this function. In front of the x squared, what does it have?
1/3.
1/3. And what's between the 1/3 and the x squared? So we have a multiplier. This A is a multiplier. It does something to the graph. If you do not have a graphing calculator, you need everyone have a graphing calculator. We have some there, and I have some black ones here. Okay, everyone needs a graphing calculator. If you need one, come get it now, please. Okay. The directions say make a graph, but not with your calculator, by using a table of values. So I'm going to give myself a table of values. Remember Ms. Gray said when we're graphing, we use at least 5 points. Now here's a hint. I like pretty numbers. I don't like to work with decimals and fractions as much. I see the fraction 1/3. Fractions are division. That says divide by 3. So the numbers I choose, my x's centered at the origin, until there's a different type of shifting, which we don't have yet, the origin 0 is going to be in the middle. My 2 smaller, my 2 larger, I want to have multiples of 3 so that I can divide by 3 and it comes out pretty. So what's a number next to 0 that's a multiple of 3? 3. Would negative 3 also work? So I'm going to have negative 3 and positive 3. What's the next multiple? Okay, good. So I'm going to plug in, these black ones will have batteries if you need one still. And show my work out to the side. The first one I'm going to plug in is negative 6. So wherever there's an x, I'm going to plug in. You have to remember order of operations. Please excuse my dear Aunt Sally. PEMDAS, exactly. Gerardo, what do we do first to simplify this? Please excuse my dear Aunt Sally. Do we have parentheses, exponents, multiplication, division, addition, subtraction? Oh, is it not Gerardo?
No. You talking to me?
I thought you were Gerardo. Roberto. Gilberto, not Gerardo. Oh. Gilbert. So, what do we do first here in with order of operations to simplify? Okay, inside parentheses all I see is a -6. I don't see much to do. After parentheses comes exponents. Is there an exponent on that -6?
Yes.
Yes. So Gilberto, sorry. What's -6 squared? Gilberto, what's -6 squared? I don't tell you in here. What's -6 squared? It means -6 times -6. -6 times -6 is 36. And divided by 3, and we have our y value. 36 divided by 3 is 12. Okay, let's do work for the next one. Y equals 1/3 times -3 squared. And exponents first on this example. Rika, with the exponents first, what's -3 squared? Good, 9. And then 9 divided by 3, because timesing by 1/3 is the same as dividing by 3. 9 divided by 3 is, careful, not 1, 3. 9 divided by 3. Yeah. Okay, another one. Y equals 1/3 times 0 squared. Well, isn't timesing by 0 just 0? That one's easy. Yes. You can go in the boundaries. Y equals 1/3 times 3 squared. Well, what's 3 squared? 9. Oh, this sounds familiar. 3 squared is 9. Isn't that the same as this guy?
Yeah.
Oh, so we found, what's this called?
Vertex.
Vertex. So we have a turnaround point, which means at 6 we'll have 12. Okay? So let's graph the function. Yes?
Okay, is there a time when there is
A vertex?
there isn't?
There is a time when the vertex isn't very obvious because the vertex happens at like a decimal. And all of these are chosen as an integer, so yes, that is the time. But a quadratic will always have a vertex somewhere. Okay? Draw yourself a graph. Don't make it itty bitty. Draw yourself a graph. Oh, I'm going to look at my y values. Why can I move this down? Because the y's are all positive except for 0. Okay, now on my x's, I put an axis, I label. I put, well, arrows as I label. I start at the origin and count out. -3, -6. And as long as I label it, Ms. Gray knows what you're doing on your graph. What should I count by on my y-axis? I could do 12, like I used to, or I could count by 3s. Yep. 3, 6, 9, 12. And as long as you give a few labels, I know what you're doing. So plot the points. Make sure it's actually a parabola. -6, 12. -3, 3. 0, 0. Oops. And then the heights repeat. Make those points large enough, thick enough, that when you graph through them, they don't disappear. And also make sure you have a curve down at that vertex. If it's not a curve at that vertex, then it's a point. That's something different. And we'll learn about that later this year. Make sure it looks like a U and not a V. So we've graphed it. We need to talk about the domain and range, and I'm guessing you've already heard about this before. The domain, I like to put a little X by it, so I remember domain is the horizontal spread following the X-axis. Okay, so if I take my marker and follow this to the left, because we always start with the smallest end first, how far to the left will we be going? See that arrow? What does that arrow mean? Keeps going. Yep, she just did with her arms. It keeps going like this. Forever, which means to the left, it will go closer and closer to which X value? Negative infinity. Will we ever reach negative infinity? No, so we have a parenthesis because we don't reach it. And to the right, how far to the right will it go? Positive infinity. And parentheses on infinities because you will never reach them. There's a difference between a parenthesis and a bracket. The range, I put a little y to remind myself. I'm looking on the y-axis now. Vertical spread. Always start on the smallest to greatest. How low does this graph go?
0.
A height of 0 on the y-axis. And is there a physical point right there at 0? Yes, so that is a bracket on 0. And how far up does it go? Infinity. We would die before we reach infinity, so we'll never reach it, so we put a parenthesis. That is the domain and range. Okay, example 3 is where you need those calculators. Example 3, we're going to graph it with a calculator to see what happens with these functions. Example 3, would you please write down on your notes these 3 functions? The first one is f of x equals negative 4x squared. We have a multiplier, negative 4. The second one, we have a multiplier of 1/4. And the third one is called our parent function. Because it's just equals x squared. It's the most basic function. On our calculators, we're going to graph these and see what a multiplier does to the function. So grab out your calculators, turn them on. Yeah, this will probably maybe be the last part. We'll see. One was negative 4, one was 1/4, and the other one was just equals x squared. Slow calculator. Uh-oh.
Oh, it broke.
I have a lot of things open, so the computer's struggling a little bit. Okay, first of all, do you know how to graph on your calculator? Y equals button. Everyone should have a calculator. Ladies, where's your calculator? If you don't have one, you're supposed to get one already. Oh, it is having a hard time. We don't need this. Maybe I should close some things. Don't need this. Don't need this. Uh-oh. It's freezing. Ah, I got it. Okay. Up on the top left, there is a y equals button. Under x1, will you put, or y1, would you put x squared? That's our parent function. Your calculator not have a, is that your calculator or one of mine?
Now you put x.
I'm sorry, I couldn't hear his answer. That's yours, okay. I just noticed you have the back. X is right here by the green alpha button. The squared is right here diagonally up from the 7. On y2, we're going to put in that first one. I think it said negative 4x squared. Do not use the minus sign. That's different. The negative sign is down here by the decimal. Put negative 4. X is by that alpha green button. X squared is diagonally up from the 7. Negative 4x squared. We're going to see what happens when we have a multiplier. To make sure everyone's calculators are graphing on the same window, would you please go to Zoom? Zoom is across the top row, that middle button. Hit Zoom and look at option 6. What does option 6 say? Z standard, a standard window. That's what we want. So everyone hit number 6. There's our parent function. Here is the second function. Okay, so what has happened on the second function? This first function is y equals x squared. The second function is y equals negative 4x squared. Raise your hand if you notice what happened. You need a graph. Oh, we're just not selected. Yeah, see how the equal sign on the second one is highlighted? See that one highlighted on the oh, it has to Okay, what has happened? The parent function's up top. How has the bottom one changed? Raise your hand if you can tell me something that's happened. How has it changed? I can see two things. Yeah? Linear. It has a vertical stretch, and that happens when we multiply by something greater than 1. What else has happened? It flipped down. That happens when we have a negative. So on your notes, that is calculus. You don't want to be doing that.
Oh, looks scary.
Okay, on your notes, remember this that we already wrote down? That A, when A is greater than 1, and it can be actually the absolute value of A, we have a vertical stretch. Some of you said it gets skinnier. Vertical stretch. It gets steeper or skinnier. The other one we didn't have time to graph. If we graphed a fraction, guess what would happen? It's not going to get steeper. What's going to happen? Wider. That's the vertical compression, because when you compress something, it oozes out the sides. So if we have a fraction between 0 and 1, we have a vertical compression. Or it's going to get wider than the parent function. And lastly, if A is less than 0, meaning it's negative, the graph flips. We call that flipping about the, well, on this one it's the x-axis. I'm not going to put the x-axis because it flips about the vertex, really, depending where it's been shifted. Okay? That's where we'll have to end. The assignment is page 116, numbers 1 through 16, 18 through 36 even. Parent teacher conference tonight and tomorrow for extra credit.
You don't have packets for us?
Oh, I do have packets. Yep, for those who need them, I do have packets.